Hey, what's going on, guys? We're back with part 17 of our learning C# tutorial, and we're going to go ahead and continue where we left off and see if we can get our player weapon to aim where our mouse position is. So we're going to go ahead and open up our player combat script, and I plan on doing this step by step just so I can we can work our way up there instead of doing it all at once and then have me explain it and then showcase it. So we can go ahead and do it in steps. First thing we can do is make a vector3. We'll call this our mouse position, or POS for short, equals input dot mouse position. Now what input dot mouse position does, it takes the X pixels from the left and Y pixels from the top of our mouse position, and then the Z is just always 0, so that's the camera position. Now we want the Z value to be the distance between the camera and the player, so we'll put mouse position dot Z equals we will do camera dot main capital C camera dot main dot transform dot position dot Z. And put a negative there. Now the reason we did this is because our player is always going to be on the 0Z position, because it's it's sort of like a 2D game with 3D assets where it's a left and right path, and so the camera's Z position is how far away it is along the Z axis, and since it's following the player and the player's at 0, it's Z minus 0, which is always just its Z position. So we can just go ahead and plug that Z position in to our position, our distance from the mouse, from the camera. And our negative there is just because our camera's probably -10 away from the player. Let me go ahead and check what it actually is. What it actually is. It's -8. So this will return an 8 point whatever, and it'll go. Our mouse position is this pixels from the left, this many pixels from the top, and then 8 units out. And so that's what that is. And let's go ahead and check and make sure this works. We'll go ahead and print the mouse position dot toString. Oh, and you notice I had a background there just for fun. It doesn't really do anything. You'll notice if you look in the log, our numbers are changing. If I keep the mouse still, it will not. However, every time I move it, it will go ahead and change the numbers. Now you'll notice that those are pretty large numbers, and the reason for that is because those are not world positions. Those are screen positions. Those are pixels from the left and right. So up the top here is a very small amount. And then the Y is down here actually. Okay, so what I want to do is convert that to our world position, and the way we do that is there's a static function we can use called mouse position equals camera dot main dot screen to world point, and then plug in that same mouse position. And what that does is just automatically convert us from pixels to world space. And so let's go ahead and save that and see now what it outputs. There we go. Now those are some more reasonable values. And you see now our Z is 0, and we want it to be 0 because that's the level where these guys are. So like our player's Z-axis, it is 0. And obviously, actually, I want to make this lower. We'll make this something like... What is that guy doing? Yeah, for some reason, I'm not sure if our sphere collision is working with our beam. I'll take a look into that in a minute. But it was working with our cubes. So next thing I want to do is actually aim towards that position. So what we'll do is fire transform dot rotation equals if I can find the Q, quaternion dot look rotation, and we will do mouse position minus fire transform dot position, and then vector3 dot up. Okay, so what this does is, just remove the debug statement. What this does is take our rotation and set it to the look rotation, which will automatically take in a direction and an up value and convert that to a rotation. So the direction is the mouse position minus the fire transform dot position. I can't remember if we talked about vectors in a previous video, but if you take one vector and subtract a second vector from it, what that is actually doing is getting the vector from our fire transform to the mouse position. So let's say right here, this is where our fire transform is, and right here is where the mouse is. The vector returned by here will be a direction from here to here. And then the vector 3 to up is obviously just up, so that it'll set this fire transform's rotation to look in that direction. We can go ahead and, oops, save this. I'm going to go in here, hit play, and you'll notice now we can go ahead and aim at stuff. You'll notice though if I, oops, that's funny. If I aim to the left here, we will actually shoot ourselves, and we don't want that. So, it'll works fine though. If we flip and then turn left, it'll works. But if we go ahead and we need to make sure that our fire transform will only rotate if we're facing that certain direction. So the last couple of videos have been really long. Well, I say really long, like 10 minutes, but I'm going to try and keep these shorter. So I'm going to go ahead and stop the video now and finish up later. It's been a long section we've been working on combat, but it should be over relatively soon. I think maybe just one more video where we do this final fix, and then we should be done.